peers. Yeah, so this is basically the GitHub repository where the cookbook will be hosted. So yeah, so as I said, it's an effort to compile large language models cookbook in different sections. So this is the third session of the large language model series. So the first session, the fourth. So the first session, we talked about the new tokenization method implemented in LLM. So that's, and then we also showed the Hugging Face implementation library of it. So that one was the very first section. And then the second session, we went through LangChain implementation. And then the third session, right before this, we talked about in-context learning. And today we are talking about this terminology called RAG. Actually, this section, it's also related to the previous three sessions of it. So we will see that RAG is actually the fundamental underlined architecture of the LangChain implementation. So RAG is actually the theoretical foundation of how LangChain actually implemented the whole workflow. And also why RAG is even possible is because large language model have this ability of doing in-context learning. So all of these sessions are actually intercorrelated. So firstly, we will say what is RAG. So R represents for retrieval. A means augmentation, and G represents generator. So now we take a look at actually how each of these things work and mean. So retrieval is actually based on similarity search. So it's actually retrieval of external new data set provided into the model as an augmentation to put in the user query in context. So generator means that it's actually using this retrieval of new data, external data set, and to put them in context to generate new stuff. So therefore, it's actually combining parametric and non-parametric into work to generate stuff. And so it's not just using the pre-trained model to generate the content. So why do we call it parametric and non-parametric? So parametric means why it's parametric model is because the model, it's still pre-trained, right? So you actually embed all these training data sets and then train it and then build in these trained data into these parameters into the model. So this model has this memory of parameters that actually are trained to learn these data. Why it's non-parametric is because these external new data set, you take them in, but you don't actually embed them into the model parameters. So therefore, it's non-parametric. So all these external new data are not really embedded into the model parameters. So therefore, but your model can still learn these through the ability of in-context learning to generate the content. So therefore, it combines both world of parametric model and non-parametric. So we talked about last session why LLM can do in-context learning and how do we interpret it? Like what is the perspective that we can borrow to interpret this ability? So we talked about how it's a sequence to sequence model, and we understanding it from the perspective of contextual embeddings, right? So we say, so it's just like those typical machine generation sequence to sequence language models. So you input your input data, then it generates a sequence of symbols on the generator side. But the in-context learning is just like the contextual embeddings, right? So the embeddings of your data are actually generated differently based on the context the language is in. So therefore, it's not just large language model like a GPT can do this in context learning stuff, but almost any transformer-based model can have this ability, which is proved in the paper. So therefore, this is the angle that we are going to understand this in context learning as well as RAG perspectives. So we will take a look at so the components of this RAG architecture. From its name, it's obviously that it includes three components. So well, it's actually essentially it's actually two architectures. So one is the retriever part of the model architecture, and then the second is the generator part of the architecture. But we would also add the second component here, which is the similarity search algorithm in play in connecting these components. So the retriever part of the model actually includes the query encoder and indexed vector database to store the information. So the query encoder is that it's basically the embedding model. And then so it's a pre-trained OpenAI embedding model it will use. So this encoder will encode the user query in a chatbot, in a Q&A machine, but it will also be used to embed the external new data set. So after you encode the external new data, which is the non-parametric part of the architecture, and then you will index these things and then store these embeddings into a vector database. So this is the retriever part of the architecture. Then after you make all these vector database ready, right, and embed everything, so what you will do is you will actually use a similarity search algorithm. Here in the RAG architecture, they're using maximum inner product search. So short name for MIPS as the similarity algorithm to return the top K results to match the user query against the external data set that is embedded in the vector database. right? So this is the similarity search algorithm. And then just like the original LLM pre-trained model, so this is still a sequence to sequence model, right? It's the very standard typical sequence to sequence model. So this is what the model architecture look like in the graph. So all of these, you can actually see it in the original paper of the invention of this RAG algorithm called Retrieval Augmented Generation for Knowledge Intensive NLP Task, right? So if I click it, so you will see it's actually this paper right here. So it's readily available on the archive. So it's basically an invention from the Facebook AI research team. Like how many authors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them, right? So they came up with this this architecture. So we can take a look at it briefly, right? Just to see what are some of the highlights or component of this architecture. So so what you do is so you can see that actually aside from the model part, right? So the input you will have in this model is the first one is the user query, right? The question queries, which is the client facing side interface. And then another part is the actually the um, external new data, because we all know so far I believe that the ChatGPT 3.5 model are trained on data pre 2021. And then I heard the ChatGPT 4 is trained on data up to 2022. So these are all trained on historical data. But what if you actually have the most up-to-date data? So the pre-trained model presumably don't know anything up to today. So, but what you can do is instead of, retraining the model again on today's data, that will actually cost a lot of resources and very expensive and not many people can afford. So instead, you actually use this RAG architecture to blend that parametric model trained on historical data and combine it with these non-parametric up-to-date latest external data. So what you would do is you would actually supply these external data into this query encoder. So from here, you actually obtain an embeddings from them, and then you store it like a cache or like a temp or like an in-memory database, right? Vector database there for use, because you have to remember once you terminate this session, right? So these are like will be gone, right? So next time you can actually use different external uh, external data with these pre-trained parametric memory, right? So therefore, these things are very easily to be made like session wise. So if you end this session, like, and then you start a new session, you can actually start with like a completely new set of external data combined with the pre-trained um, parametric model, right? So after you do this, like say in this session, then what you would do is you use this MIPS similarity match algorithm to find the top K most similar embeddings to your user query, right? And then you will use those top K embeddings, right, as the basis to form your context to put to submit them into the GPT model to generate stuff, right? So therefore, so you have to remember here, right? The contextual embeddings that you use are not really on the embeddings of the user query, but rather it's actually the embeddings of the knowledge base, right? Of those external database. So therefore, some people say that this architecture somehow ground user query into more factual basis. So then the content being generated will not go crazy, right? So then, because the embeddings that you use, it's actually based on some factual data that you submitted to the model. So the model will just not go like uh, generate some crazy stuff. Like it's based on some data that so it will be evidence based, right? From these external data that you provide to the model as the context. So another thing here you see is that it's also using some indexing algorithm for the documents. So we will see later today that a lot of the times if these documents are too big, right? So then you would actually need to think about a way to scale this processing, right, in a distributed way. So before actually PyTorch or Hugging Face, they actually used some way to try to implement that, but then that was like so far not really the state of the art method so far. So actually, there's a library called Ray. RAY, so it implements this distributed retrieval algorithms, right? That is chunking and these retrievals of large index document vector base in the most scalable way. So we will see that like at the end of the session today. And then so after you retrieve this, then you submit these contextual embeddings into this generator part, right? So you see that this generator part is actually the parametric part of the model, the architecture, and this retriever part is the non-parametric part of the model, right? And then so from there, then it actually generate a sequence of things. So you will see that it's still a sequence to sequence model, right? End to end. And so we also encourage you to review how LangChain implemented this in-context learning and basically this RAG model, which actually we touched a point in our second previous session about it. And then we also talked about, the why is it both combines both the parametric part of the world as well as the non-parametric memory, right? To work together in LLM. So I think we also talked about like basically how like what does RAG do, right? Just from explaining the architecture part of the model. So we will just emphasize again that why even all of this work is all because of the fact that LLM has the capabilities of doing in-context learning. So if it was, like some previous model like before, if it's a non-transformer based model, all of these, like even if you made this architecture, it would not work, right? It's because it's all because transformer-based model, it has the ability of in-context learning. So if it's a model without the ability of in-context learning, so all these RAG architecture would not work, right? So and then actually the paper I mentioned above there from the Facebook AI research team, they actually claim with this architecture of in-context learning, it actually beats the state of the arts model at the time, right? So so the generator part, with the provided context from the external augmented data, it ground the large language model onto some updated facts, right? So it prevents LLM leaking sensitive data or hallucinate, right? So because we all know that we like some people claim that just LLM makes up too much stuff, right? Without this thing, like let's say that if you start querying ChatGPT without these in context learning, just the vanilla ChatGPT about stuff, everybody knows it starts to make up stuff, right? Just like starts to hallucinate and makes up random things. But if you actually supply the original vanilla ChatGPT model with these external data, updated data, it kind of actually, make the the content generated from ChatGPT more down to earth, right? That's what grounding means. So it's all enabled by this RAG architecture. So that's why, it always serves you better if you actually not just using the vanilla ChatGPT bot model, but actually bring it into a context, right, with your updated data. So, so I would like to actually show you that. This one is what Hugging Face. They actually implemented this RAG. So this is the IBM also did some research about this about RAG, but this other implementation is from Hugging Face. So it already include this RAG model in their transformers library, right? So you can see actually how they implement this RAG model. So another thing I would like to show you is they actually use this. You see, actually, you okay, why is it going here? So you actually see it also using this RAG Ray library, right? So this Ray, so before they use this torch distributor. So all of these are actually implemented in PyTorch. So before they were trying to implement this in this distributed library in PyTorch package, but it's actually not the most ideal way implementation. So therefore, they actually do it this way in this Ray library in the more scalable way. So you can see, take a look at these are the more up-to-date, state-of-the-art implementation of how to, it's mostly to optimize the distributed retrieval in a parallel way, right? From these large external data set that you actually index them into your vector base. So I encourage everyone to also, if you have a free time, to just explore these libraries, that how it actually made everything 2 times faster, right? That's what the claim is. from the original PyTorch distributed library. So yeah, so that's pretty much what we mean for today's session. So just to see what if anyone has any questions about it, so we will take people's question about things.